Welcome to EDU World Space.
Okay, so we're doing chapter 32, problem 56. So what this says is for visible light, the index of refraction in of glass is roughly 1.5. So let's write that down, 1.5. Although this value varies by about 1% across the visible range. Okay, so if this is varying across the visible range, the delta N is equal to about 1%. Or 0.01. Okay, so consider a ray of white light incident from air at an angle theta 1 onto a flat piece of glass. So coming in at theta 1 from air onto this glass, we want to show that upon entering the glass, the visible colors contained in the incident ray will be dispersed over a range delta theta 2 of refracted angles given approximately by this formula. Okay, so what we want to figure out here is our delta theta 2. Let's figure out what this is. So they do give us a hint. They say for x given in radians, we can write d dx of the inverse sine of x as 1 over the square root of 1 minus x squared. Cool. So this is our hint here that they give us, so we're going to make use of that. So first, let's use Snell's law to solve for the refracted angle theta 2. So we know that n1 sine theta 1 equals n2 sine theta 2. Since n1 is air and n2 is our glass here, we can just take n1 to be 1 and then say n2 is n. So then we rearrange and we see that theta 1 is the inverse sine of sine theta 2. Oh, sorry. This is theta 2 we're solving for, so this is inverse sine of theta 1 over it. Perfect. So now we're trying to find the change in theta 2 across this from the change in index of refraction. So what we can approximate the change in theta 2 over the change in n as the derivative with respect to n of this function we have here of theta 2. Okay, so with this approximation, we can now take the derivative of this function. So using our hint, if we take theta 2 to be in radians, we can now use this derivative identity over here to solve for this. And what that gives us is that d theta 2 dn is sine of theta 1 over n squared square root of 1 minus sine squared theta 1 over n squared. Cool. So if our delta theta 2 over delta n can be approximated like this, we can now solve for delta theta 2. And this is approximately delta n sine theta 1 over n squared square root of 1 minus sine squared theta 1 over n squared. So we can now simplify this and pull in one of the n's from here into the square root, and we're left with delta n over n sine of theta 1 over the square root of n squared minus sine squared theta 1. And this is approximately our delta theta 2, which is exactly what we wanted to show. Cool. So now let's move on to part B. So part B says for theta 1 equaling 0 degrees, what is our delta theta 2 in degrees? So delta theta 2 is given from this equation. So all we have to do now is plug in our stuff. So delta in is 0.01 over 1.5. And then sine of 0 degrees over square root of 1.5 squared minus sine squared of 0 degrees. So if we solve that out, we should see this is just 0. Cool. So now let's go to a new page here for part C. So for part C, it says if theta 1 equals 90 degrees, what is delta theta 2? Okay, so now we can just start plugging this in here. We should see that delta theta 2 is equal to 0.01 square root of 1.5 squared minus sine squared of 90 degrees. This is all over sine of 90 degrees. And we should see this is equal to 0.089 radians. So then the answer wants us in degrees, so we're going to have to convert this back. So we just multiply by 180 over pi, and this should be 0.5 degrees. And this is our delta theta 2. Awesome.